Hello friend, welcome back to Get Up. My name is Vikas. In the previous video lecture on the introduction part of engineering mechanics, we have studied how this engineering mechanics has been derived from mechanics. Okay, and in the engineering mechanics, we are going to study the effect of forces on a rigid body. Along with that, how this engineering mechanics is classified into statics, dynamics, and kinematics. Okay, and also in the previous video lecture, I have told you the difference between a rigid body and a deformable body. So now today onwards, I am going to start with the starting with the syllabus, covering the syllabus of GATE syllabus of engineering mechanics. Okay, and today we are going to study the what are forces, what are different types and system of forces. Okay, so let's start. Now, when you hear the word force, so first thing that comes into your mind is you are pushing someone, okay, or pulling out someone. So this was the something that if you make a picture of something in your mind when you hear a word, so picturing yourself on hearing a force is something that you are applying a muscular force on a person and you're pushing someone or pulling out someone. Okay, so the basic definition of the force is that force can produce push, pull, or twist in a body. Okay, or you're twisting someone. Okay, you're twisting your hand like this, so you're applying force on your hand. Okay, so this is all different kind of forces. Now, so do you really think that pushing someone, pulling someone, or twisting out a body is a force? Okay. Now, force is an agency which changes or tends to change the position of rest or of uniform motion of a body. Okay, or it has the capacity to impart motion to a body. Okay, so there are different kinds of forces. Okay, that we are going to study in this video lecture. Now, what are characteristics of a force? So, force, first thing I want to tell you, force is a agency or a quantity which has got a magnitude along with a direction. Okay, so it is a vector quantity. Force is a vector quantity. Okay. Now, there are the three quantities required to completely define the forces are called the specification or characteristics of the forces. So there are basically three characteristics of the forces. One is magnitude, one is point of application, and direction of application. So how I'm going to tell you this? Suppose that you are standing somewhere. Okay, you are standing here and you are applying a force. Okay, now initially the force that you have applying to push an object, suppose this is a body and there is a person was trying to apply force to this body. With the force applied initially is 2 kilonewton. Okay, so with 2 kilonewton, the person is pushing a body. Okay, suppose this is a body. Okay, and person is pushing it with this force. Now, if I increase the force to 5 kilonewton, so the motion of the body or the velocity in the body will increase. Why? This force is proportional to mass into acceleration. Okay, and acceleration is nothing but rate of change of velocity. Okay, and velocity is a rate of change of displacement. So I hope this thing you have revised your concept on displacement, velocity, and acceleration. Okay, these are three vector quantities. A rate of change of displacement is velocity, and rate of change of velocity is called acceleration. Okay, and this force is equal to mass into acceleration. This is nothing but Newton's second law of motion. Okay, so now if I increase the magnitude of the force, okay, or if I increase this quantity of the force, then there is a change in the acceleration, the velocity of the body with which this body is moving or we are pushing it. Okay, so that means this force has got a magnitude. Along with that, if I am standing at this point, okay, and from this point if I am applying the force, so this force has also got a point of application. And the third thing is that force, since is a vector quantity, if I am applying force in this direction, then, and if I am changing the direction of force, if I now push this block in this direction, x-axis, then y-axis, or if I am pulling it like this, pulling it on my shoulder, okay, pulling this block and keeping it on your shoulder, then this is called other force. Okay, you are applying the force in this direction, vertical direction, or you can apply the force in horizontal direction. Okay, so this force has also got a direction. Now, what is composition of force? So, as I have told you, these forces, if they are acting in different direction, x direction, y direction, z direction, different direction. Okay, so since there are three different axis, x axis, y axis, and z axis, if the forces are acting in different axis, okay, so how we are going to tell you that what is the total amount of force which is acting on the body if the forces are acting in different direction? So that is called the composition of forces. If the reduction of a given system of forces to a simplest system is called a composition of the forces. Okay, now this reduction of the forces or composition of forces is determined by two laws. One law is called parallelogram law of force, and that is called triangle law of forces. Okay, so in the parallelogram law of force, suppose that if the forces are represented by two sides of a parallelogram, okay, suppose this is force P, okay, this is force Q. Okay, now these forces are represented by two sides of parallelogram. So the diagonal of this parallelogram, after completing this parallelogram, okay, so this will be the force P, this will be the force Q. So the parallelogram is completed. Okay, now the diagonal of this parallelogram will represent the resultant of the forces. Okay, now if these forces are taken in the same order of the parallelogram, suppose this is P and this is Q, if the forces are represented by two adjacent sides of the parallelogram, okay, now if I complete this parallelogram, this will be P and this will be Q. Now the diagonal of this parallelogram will give you the resultant force, and this force will be the sum of P and Q, or individual forces taking in the same order at the adjacent side of the parallelogram. Okay, now if the order is not same, okay, suppose this is force P and this is force Q, so then the resultant force will be represented by the diagonal itself, but the resultant will not be P plus Q. This will be equal to under root of P square plus Q square plus 2 into P into Q into cos theta. Okay, what theta is the angle between these two forces. Okay, so this theta is the angle between force P and force Q. Okay, so the magnitude of this resultant force will be equal to under root of P square plus Q square plus 2PQ cos theta if the forces are not taking in the same order, or you can say not taking at the adjacent side of the parallelogram. So this is called parallelogram law of forces, and this is how we find the composition of two different forces. Okay, second law is called triangle law of forces. In the triangle law of forces, we assume that if two forces are taking place in as adjacent sides of a triangle, okay, if they are represented as an adjacent side of a triangle, then the resultant force will be represented by the closing side of the triangle taking in the opposite order. Okay, so suppose that these are two forces P and Q. These are two forces, and if I complete these two forces, then it will be a triangle. But are these forces taken in the same order? No. This force is P and this is Q. They are in the opposite direction. Okay, direction should be opposite, but they should be taken at the adjacent side of the triangle. But this is not the adjacent side. Okay, now if this force P is taken same, and this force Q, which was presently here and making angle theta here between P and Q, now the force Q is shifted to this place. Okay, and now this is represented at the adjacent side of the triangle. Now the direction of motion of the force P is P this, and Q is this. Okay, now the resultant force will be represented as the closing side of the triangle, and this will be taken in the opposite direction. This resultant force will be the sum of P and Q. Okay, so this is how you will find the resultant force with the help of triangle law. Now this was one method to find the resultant force. Suppose you want to find the individual forces which are acting on this sides of the triangle. So how are you gonna find this? This is determined with the help of a law called sine law. Okay, suppose this is a triangle and the angle between two sides, this is alpha, this is beta, and this is gamma. Okay, now as you know that this angle opposite to side P, force P is gamma, force Q is, this is force Q, this is alpha, and force R is, resultant force is beta. So by sine law, this is represented as P over sine of gamma equal to Q over sine of alpha is equal to R over sine of beta. Okay, so this is how we can find the forces, individual forces, with the help of sine law, if you know the angle between two sides of the or two forces. Okay, now what are different kinds of forces? Okay, so the forces are basically classified into two types. One is called contact force, other is called non-contact force. Now as the words say, contact and non-contact, if the forces are acting in such a manner that the surface on which force acts are in direct contact with each other, then it is called contact force. And the forces which do not require a contact with the surface of the body on which force is acting, then it is called non-contact force. So the example of non-contact force is gravitational force. Okay, so no matter if the body is located in which place, okay, you don't require a direct contact with the body, then this force is called gravitational force. Similarly, Coulomb force. Coulomb force is the force between two molecules or two charges. Okay, and this force of attraction also do not require that the two molecules on which charges are there, they don't need to be close to each other so that this force is applied. Okay, so they will be attracted or under the force of attraction of this Coulomb force, but they do not require that the forces are touching or in contact with each other. Okay, so these gravitational force and Coulomb force are example of non-contact force. Other is called contact force. So contact force example, push and pull. Okay, body force, point force, distributed force, external, internal and frictional force. All these forces are called contact forces because they require a surface contact for force to act. Okay, so contact force, you know that for pushing someone, you're required to be in contact with the body on which you are applying the pushing force or pulling it. Okay, body force is a force which is contained by the body. Okay, this is also called body force. Okay, then point force. Point force, suppose you are applying force at a particular point. You are applying force at a particular point, then that force is called point force. And distributed force is if the forces are distributed over a surface. Okay, F1, F2, F3, F4, F5, then those forces are called distributed forces. Okay, internal force, if the forces are acting inside the body. Okay, suppose you are applying a force P. So this force, the forces which are generated inside the body due to this external force are called internal force, and this internal force gave the concept of stress in strength of materials or in deformable bodies. Okay, so this is also internal force, and this internal force you are going to study in strength of material, but in engineering mechanics you are only focused on these external forces. Okay, or external force which is applied on the body, but internal force gave the concept of stress, and that you will be studying for deformable body but not for rigid body. And the last is frictional force. This is also kind of external force which takes into action when you apply force on a body. Suppose you are pushing a body with a force P. Okay, now in opposition to this motion, which is when this body is applied with a force P, this body starts to move with a velocity V. So in opposition to this motion, there will be a force called frictional force, which will be trying to oppose this motion. And this is by the Newton's third law of motion, that if a force is applied on a body, then definitely there will be a reaction to that force, and this is nothing but a reaction force is called frictional force. Okay, so this is what was some classification of different types of forces. Now if we talk about what a system of forces, the system of forces is nothing but how the forces are acting on a body. Okay, and that is called system of forces. So these are basically classified into four main categories. First is called concurrent forces, then collinear, coplanar and parallel forces. So these are some system of forces. What is the behavior of the forces which are acting on a body, okay, and how they are acting on a body. So coplanar forces, concurrent, collinear, coplanar and concurrent, coplanar and non-concurrent, non-coplanar and concurrent, and non-coplanar and non-concurrent, and like and like. So we'll study this force system in detail. Now first is coplanar forces. Coplanar forces are the forces whose line of action lie in the same plane. Okay, suppose this is a plane. Okay, this is a x and z plane. Okay, this is a x and z plane, and the forces are acting such a manner that their line of action is lying in the same plane. Only in this plane the forces are acting. So this is called coplanar forces. Next is called concurrent forces. So concurrent forces means con means same and current means at same point. The forces which are acting at the same point are called concurrent forces. Okay, so suppose this is force F1, this is F2, and this is F3, and all these forces are meeting at same point called point O. So this force is called concurrent forces. Such a system of force is called concurrent force system. Next is collinear forces. All the forces whose line of action lie in the same line are called collinear forces. So if the forces are acting on a body and these forces are acting on a same line, so those forces are called collinear forces. Now these were some main classification of the system of forces. Now we will be trying to couple this system of forces. So first system of force, combination system of forces is called coplanar and concurrent. So as I told you, coplanar is when the line of action forces lie in the same plane, and concurrent is when the system of forces are acting at or meeting at a same point. So coplanar and concurrent forces will lie in the same plane, the plane will be same, and all these forces will be meeting at a same point. So this is the same point on which forces are acting, and these forces are lying in the same particular plane. Next is called non-coplanar and concurrent forces. So concurrent means all the forces are acting in the same point. Suppose point of interaction of all the forces is same, but the plane is different. Now the plane has been resolved in three directions, x, y and z. So the forces are acting in different plane. Okay, so if the forces are acting in three directions, x direction, y and z direction, that means the plane is not same. Okay, then we can't say the forces acting in the same plane. The plane is different now, but the forces can act at a same point. Then it is called non-coplanar and concurrent forces. Next is called coplanar and non-concurrent forces. So coplanar means same plane, and non-concurrent means the line of action of the plane are not of the forces are not acting at the same point. So this is the line of action. This force is meeting at this point. This force is meeting at this point, and this force is meeting at this point. So all the forces are not meeting at the same point, but the plane is same. So that is called coplanar and non-concurrent forces. And then is non-coplanar and non-concurrent. That means neither the same is plane and neither the forces meet at the same point. Okay, so that is called non-coplanar and non-concurrent forces. And the last is called parallel forces. All the forces whose line of action do not lie on the same plane and they don't meet at the same point. Suppose that the forces are acting at such a manner that they are not lying in the same plane, but they are parallel to each other. Okay, they are at a fixed distance to each other. Then those forces are called parallel forces. Now these forces are of two types, like parallel forces and unlike parallel forces. Like parallel forces are those forces which are acting parallel to each other, but they are in the same direction. Okay, then these are called like parallel forces. But if the forces are acting in the same parallel to each other, but they are not acting in the same direction, then these forces are called unlike parallel forces. Okay, so these were some classification of the types of forces and system of forces. Okay, I hope in your exam, if you are given a diagram in which this different forces system are given to you, so you can identify it clearly that what kind of system of forces is there. Okay, so this is all for today. Today we have learned about what is a force, what are different kinds of force, and system of forces. In the next video lecture, we will see how we can analyze those forces on a body with the help of a diagram called free body diagram. Okay, so in the next video lecture, we will be studying free body diagram and resolution of forces, how the forces are resolved, okay, if they are acting in different direction, and finally what is the effect when the forces are acting in equilibrium. Okay, so all these three things we'll be studying in the next video lecture. So this is all for today. Thanks for listening. Have a nice day. Thank you.